bloody fly got into my booze. I'm pissed off. This one is the square root of x plus 1 plus x dx. So, when I'm looking at this integral, that root x looks like it's a real pain in the ass. So what I'm going to do is I'm going to do a u substitution to get that power to something more manageable. So I'm going to put u equal to root x, right? And then look at, there's an x over here. So if I square this u, this will be x, right? Now, I could deal with that because I got a smaller power on the bottom and one on top. This looks like it actually could work, right? This could be something cool. But there's this dx here, so I have to take the derivative of this, and I get 2u du equals dx. Now let's just substitute it in here and see if the magic will happen. So what I got over here is, on the top I get u, right? And on the bottom I have 1 plus u squared. When I think about 1 plus u squared, I think about the derivative of the inverse tangent. Let's not get ahead of ourselves yet, but that looks very, very doable. And then, I still have this dx over here. So I have to multiply this by 2u du, right? Now, after I multiply this out, is everybody with me still? I get 2u squared over 1 plus u squared. And I look at that and go, okay, I can take that 2 because that's a constant, and I can stick that on the outside. Of course, du. So, go away. It's not dx, it's du. So, there's this cute little trick that I learned about how to deal with something where the top looks very, very similar to the bottom. And this is a real cool trick. Let me show you this trick. So, I'll start over here. So you have this integral. We have this u squared plus u squared essentially plus 1 du, right? Well, what if you put the plus 1 here? Because now that's 1, correct? And then what I could do is, because I added 1, all I have to do is subtract 1 and everything is the same, right? So I could do minus 1, right, du. Look at this. So then you can see you could put a little bracket there, and essentially it's the same, right? So now, look at, I have 1 over u squared plus 1, and over here I have u squared plus 1 again, and then I have a negative 1 over this. It's like everything seems to be working out very, very well. So what we're going to do is we're going to split this fraction into 2 parts. 2 times the integral of u squared plus 1 over u squared plus 1. And we'll split that. And of course, this is the 2, we'll keep it over here, of 1 over u squared plus 1 du. Look at this. That's 1. That, right? So now, let's take this integral. 2 times the integral of 1, which is u, minus 2 times the integral of 1 over u squared plus 1, which is the inverse tangent of u, right? So, the only thing that really remains is to put the x back. So, should be pretty simple, right? I set u equal to the square root of x, remember? So now every time you see you put square root of x, okay? 2 times the square root of x minus 2 times the tangent of the inverse tangent of the square root of x plus c. And that, ladies and gentlemen, is the integral. Join me next time when flies don't fly into my booze and piss me off.